Hi, I'm Paul. Let's move to the next topic with the vector value motion along a curve. So there are some reminder here. For displacement to velocity, you need to use differentiation, velocity direction, also differentiation. You want to do it the backwards, you need to use integration. So it's quite important because we are using it for the following question. Let's look at the question. So the question is, how do you kick a soccer ball from the ground on a field? So let me draw this. Adi, you're kicking a ball along a curve, something like this. So along the curve, the position of the x will be using this equation, or the y will be this equation. Okay, so these two are displacement. So s is and this x and y. Okay. So let's look at the first sub question. Let's find the velocity vector when t equal to 1. So this displacement, like I said before, is x, is y. So you want to find velocity, you need to use differentiation. So when you differentiate, it will become like this. Okay. So the question is find the velocity vector when t equal to 1. So is you sub the t equal to 1, for x you get 6, for the y you get 5. Okay, so let's look at the sub question number 2. Find the acceleration vector when t equal to 1. So you want to find acceleration vector, you need to differentiate the velocity vector equation. Okay, so you differentiate, you differentiate this, you get this, differentiate this, you get this. Where this x for x, this for y. Okay, so the question is find the acceleration vector when t equal to 1. So sub t, t 6 times 1 is 6, 24 times 1 minus 6 is 18. Okay, this is the answer for this sub question. So let us look at the C. C, we need to find the equation of tangent line when t equal to 1. So this is the curve, the tangent line, and t equal to 1. Okay, so we need to find the m. Okay, the m is equal to dy dx. By using this, dy dt times dt dx, you'll get dy dx. So we already find it in the previous question because it's the same is t equal to 1. So you get from the previous question is dy, this dx dt is dy dt. So you get the 6 for dx dt, so it's 1 over 6. So it is 5. So and you need to find the coordinate for this location. So it's very simple, you just substitute with the s equation. Or 2 minus 1, you get a 1. This is the coordinate. So by using the equation y minus y1 equals y is 1, the xy is 4, the m is 5 over 6, and you substitute all the thing and do some math and you get something like this. Okay, and that's it for me. The rest I'll leave it to Mr. Yap. Thank you.
So hi everyone, my name is Yap. So I'm going to continue the explanation for the next sub question for motion along a curve. So for D, they give us a new situation. They tell us that RD kicks the ball again and the ball is moving at a speed of 6 meters per second at 50-degree angle. Find the vector valued function that's described its position as a function of t, and assume g equals to 9.8 meter per second square. Okay, so this is important here. G equals to 9.8 meter per second square. Okay, so I'm going to draw it out to have a better, so you guys have a better understanding. So Ali kicks the ball again. Okay, and the angle he kicked is 50 degree, and the initial velocity u is equals to 6 meter per second. Okay, so basically the question have already given us the info for acceleration. So first we are going to construct the vector valued function for acceleration first. So yeah, before I start explanation, just an reminder for you guys, for us to find the position vector value function from the acceleration equation, we have to integrate it from acceleration. If you want to find velocity, then only we'll find displacement. So in this direction, we are going to integrate in order to find the displacement. So first we are going to start here. So we know that the acceleration is 9.8 meter per second square. So since the ball is going opposite of the force of gravity, so we are going to negative the g for j component, negative g. So the acceleration vector value function is 0 and negative 9.8. So yeah, next we're going to find the velocity vector value function. So how do we find the velocity vector value function? Basically we just integrate this acceleration vector value function. So after the integration is done, we get this value 0t plus c1 for I component and negative 9.8t plus c2 for the j component. So you may be wondering, what's c1 and what's c2? So basically c1 and c2 is the I and j components for the initial velocity of the ball. Okay, so how do we find it? So I'm going to show you guys how we find it. Okay, so according to the question, he kicks the ball at 6 meter per second square. We're going to use trigo here, 6 meter per second. Okay, now here's the 50 degree angle. 50 degree. Okay, so this one is I component for the initial velocity. This one is initial velocity. Take note now. This one is initial velocity of the ball. So I component for initial velocity and J component for initial velocity. So how do we find the I component for initial velocity? Basically, we use cos equals cos is k, right? Adjacent and hypotenuse. So I cos 50 degree equals to I over 6. Then we get I equals to 3.86. For sine is sine opposite over hypotenuse. So opposite is J over 6. Then we calculate, we get I equals to 3.86, and J equals to 4.60. Basically, we just sub both of these value into this function just now, vector value function just now. So after substitution, we'll get 3.86 for I and negative 9.8t plus 4.6 for J. Okay, so now we have found the V. Okay, next we are going to integrate the V again, and so that we'll be able to get the displacement vector value function which the question asks. Okay, so now this equation, we integrate this vector value function for velocity. So after integration, we get 3.86, integrate, get 3.86t plus c3, negative 9.6, integrate, we got negative 9.8t squared over 2, and plus 4.60t plus c4. Okay, again, you may ask, what is c3 and what is c4? C3 and C4 is basically the initial displacement, initial position of the ball before Ali kicks the ball. Okay, so let's look back at the question. Ali then kicks the ball again. The ball is moving at 6 meter per second at 50-degree angle. Find the vector value function that describes its position as a function of t. So according to the question, they didn't give us the initial position of the ball. So now we are going to just assume that the initial position of the ball before Ali kicks it is 0, 0 for I, and 0 for j. Okay, so the initial position of the ball before Ali kicks have a I component 0 and j component 0. So we're going to substitute 0 into this C3 and 0 for j component into C4. So after the substitution, we'll get something like this: 3.86 t for I, and negative 9.8 divided by 2, you get 4.90 t squared plus 4.60 t. So C4 is 0, so nothing here. So yeah, here's the final answer. So the vector value function that describes its position, describes the position of the ball, is dt equals to 3.86 t for I component and negative 4.90 t squared plus 4.60 t for j component. So that's it for me. Thank you for watching.